All right, so today we are looking at 6.4, which is efficiency and saving energy. Okay, so the first part of this lesson is comparing light bulbs because light bulbs produce light, but um, they also produce some heat. The purpose of a light bulb is, however, to produce the light. The heat that is produced, it's like a wasted energy that is produced as well as the light, but it's not what the light bulb is meant to do. So when we look at an incandescent light bulb, they convert their electric energy into light energy. So incandescent actually means glowing with heat. So these bulbs, they produce light when electricity flowing through the filament makes the thin wire white hot. So right here. And some of that electric energy is converted to light, but a lot of it is getting converted into other forms of energy. So, for example, heat. So, efficiency it's a measure of how completely input energy is converted to accomplish the desired output energy. All right, so it's very important here to note the desired output energy. So when we're looking at light bulbs, the desired output energy is the light. We want the light, but there are other forms of energy that are converted as well, which is, for example, the heat energy. All right, so we're comparing the incandescent bulb here with a fluorescent bulb. And what we know about these two bulbs is that they produce about the same amount of light. However, incandescent bulbs produce more heat. And therefore, these incandescent bulbs, are less efficient than the fluorescent bulbs. All right, so now we're looking at efficiency as a percentage. So if we're looking at a motor, for example, and if it's 80% efficient, that means 80% of the input energy is converted to do the intended job. So for example, if it was a motor, the intended job would be for the movement. All right, but that means 20% of the input energy is wasted. All right, so 80% efficient, 20% is the wasted energy. Okay, so remember efficiency as a percentage, so it's out of 100. So how you determine efficiency is using this formula down here. Basically, you divide the useful energy output by the total energy input, and then you multiply by 100 to get it expressed as a percent. All right, so let's take a look at an example here. We have an electric kettle. It uses input energy of 240,000 joules to heat water. 196,000 joules is actually used to heat the water. Calculate the efficiency of the kettle. All right, so we're going to use our four-step method again to solve these problems. So we'll start with what do you know? So we know that the energy output is 196,000 joules, and we know that the total energy that was input is 240,000 joules. And what are we trying to find? We're trying to find out the efficiency of the kettle. All right, and we're going to use our efficiency formula, which is the useful energy output divided by the total electric energy input, and then we're going to multiply by 100. All right, so it's 196,000 joules. That is the useful energy output divided by 240,000 joules, which was how much energy was input. And then you multiply by 100, and we get 81.6%. Lastly, you would just summarize with a sentence. So the kettle is 81.6% efficient. If you rounded that, you could round it up to 82% efficient. Now, why is it important? Why is it important to be efficient? Why is it important to conserve electric energy? So first of all, you're going to save money. So if you use less electricity, you'll save money on your monthly electric bill, your monthly utility bill. Secondly, using less electricity is also beneficial to the environment. So in Alberta, most electricity is generated using fossil fuels, and most of that comes from coal burning power plants. But we know that as coal burns, it produces carbon dioxide, sulfur dioxide, and nitrous oxide gases. These get released into the atmosphere, and they have been linked to global climate change. Sulfur dioxide and nitrous oxide as well also cause acid rain and acid precipitation and acid deposition. So using less electricity means that fewer harmful emissions are released into the environment. All right, so we do have a quick video here. It's a brain pop on conserving energy. We'll play that in a second. And we are finished chapter 6. So for today's homework, it is the 6.4 questions and then the chapter 6 review questions.